I'm going to go to the one of the parsing stop things.
Okay. So today would be chapter 8, electronic configuration and periodicity. Let me turn off the door. Okay. The chapter today is a couple of things, guys. Gonna be reviewing chapter 7, and a lot of things are new. And chapter 8 is very, very extremely important. The reason extremely important is chapter. No, I didn't mean you. I was just talking. So chapter 9 and 10 is very much depending on this chapter, how much you're understanding. The material you have, very few. We'll be covering some fundamental rules of electronic configuration. We'll be going over in-depth practice and explanation on electronic configuration. Then we'll go a couple of new vocabulary and then some terms on periodicity. Okay, that's all in the chapter. So today we'll be finishing about 70% of the chapter, and next class will be wrapping up the rest of the part. So first of all, electronic configuration and periodicity. First of all, I would go with some fundamental handy rules. I say handy because these rules you need to write configuration of atoms. The first one is off-bow principle. Off-bow principle is when you have a electronic configuration, electrons keep filling from lower to higher. It follows in order. So what is the order? That's what above said. So if I go back to the previous chapter, you guys can remember that. So in previous chapter, we talked about that different energy level of atom, right? You remember that? Different energy level? So first level, second level, third and fourth level, right? And in the center you have a nucleus. So if you just kind of refresh your mind from the last class, level 1, what did you have? Which orbital was allowed in level 1? If n equal to 1, level 1 would be n equal to 1, right? If n equal to 1, which orbital are going to be allowed? S, exactly, 0s, thank you. How about group 2? Level 2. So level 2 is energy level, right? So if n equal to 2, which orbitals are allowed? S and P, wonderful. S and P, right? If n equal to 3, what are the permitted orbitals? S, P, and D, right? How about the last one, 4? So this is a 4 allowed level. So when your electron is filling up, Off-bow said that electrons are filling up from lower to higher in a certain order. What is the order? Order is simply that 1s, 2s, 2p, 3s, 3p, 3d. You see that? Then 4s, 4p, 4d, 4f. Isn't it very orderly? Logical that we learned last class? Nothing new, right? Very just in orderly fill up. That's called off-bow principle. And this, before going to second rule, I like to show you there is some hiccup, I can say, discrepancy on their order. So let me draw it out. So we go with a 1s, 2s, 2p, 3s, 3p, then 4s, and then 3d, wonderful. So it keeps fill up like that, right? So 4p, so 4s, 4p, and then 6s. Sorry, 5s. So level 1, until level 2, until level 3, and until level 4, right? And then 5. So then 5s, then after 5s, there will be 4d. Right? And then, so it keeps filling up. You see 1, 2, 3. You might expect it that after 3p, based on this, 3p, then 3d. But what happened? 4s come 3d. Let me write out the 1, 2. So you expected that 3d, 4s, and then 4p, 4d, right? That should be the order. That's what we have learned, no? Isn't it?
Isn't there like a little pyramid that tells you like
Yes.
goes perfectly or something like that?
Then the pyramid types, yeah, we can follow that one too. So I'm just kind of going to the, very basic, how it came in this order. So what I said that this is the one we expected, right? But it gets a little bit, pick up right in here. 3D coming after 4S, where 4S you expected that would be higher in the following level, one level up, right? Let's keep it. So that's the order is called above principle. Electron goes here, then here, then here, then keep going. Okay? And the second, I have this in order in the PowerPoint. The second is Hans rule. Hans rule is, Hans says that electron fills odd number possible. Hans talked about more in electron orbital. When they look exactly orbital, they fill out their odd number possible first. Then they go become even. So how is it? For instance, if you look at periodic table, everybody today class periodic table is extremely important. You always keep it handy. Whatever you need, you can take a look. So if you look at the periodic table, for example, I go for carbon. So if I draw the carbon for carbon is, let me draw in here. So for carbon is 6. So carbon is 6. If I draw SPD, so if I get 6 electron, it will go S first, then P. Keep filling up, right? So if I go S is like one orbital, one compartment. And then 2s. And then 2p. You see? It may be unknown to you right now. It's going to be very easy for you. Just in a moment. Remember that s orbital can occupy highest 2 electrons. We talked about that last class, right? S can have 2 electrons, P can have 6 electrons. You remember that? Yes or no?
Yes.
So S have 2 electrons, that means 2 electrons can be one orbital. But P can have, so let me write out in here. So S can have 2 electrons, okay? P can have 6 electrons. And D can have 10 electrons, and S can have 14 electrons. Okay? So if 2 electrons is going to be one compartment, and if 6 electrons, it needs 3 compartments, because each compartment, I say is my word, I use that. Each part of the orbital or each compartment can have base 2 electrons. If that is the case, to carrying 6 electron, it needs 3 compartments, isn't it? And if I go for D, it's going to be 5. F is going to be 7 to fill out maximum number of electrons. So Hunt said that if you fill out orbitals with electron, they will go odd number first. They will go odd number first. How it is? Carbon have 6 electrons, right? So 6 need to be distributed throughout the orbitals. So 6, I got 2, so each one can get, so first is going to be filling out the S, because look at the 1s first, then 2s, then 2p. Does it make sense? So 1s, 2s. Then it will fill out this first, so I got 6 electrons, then I got 4 used up. I got 2 more. When I got 2 more electrons, I can fill out this way, right? Can I? Yes, I can. But technically I can. But Hunt said that I cannot. He said that in a same orbital, it go maximum odd number possible. So this will not be going here, the other go in here. You see? So this is a 6 electron, that's how it fill up. That's the Hunt's rule. If you see in terms of, this is a nitrogen example I have. Nitrogen, I have 6 electron, 2, 2. It could be possible this would come here, no. They have to be single maximum possible. But if you get, instead of nitrogen 7, if you get 8 electrons, that would be 8, last one will come here to make it even. Until that, there will be single. So that's the one structure of orbital, Hunt said. The last formula I have, Pauli exclusion principle. It is, Pauli exclusion said that no 2 electron can have same quantum number in an atom. So electron in an atom have to have its own quantum number, which means that, like right here, look at here carefully. You have 2 electrons in here, right? In 2 electrons, they are opposite. You cannot make both of them in the same spin. It has to be opposite spin. So 2 electrons cannot have same quantum number in an atom. So that must be, if I have 2 electrons, that must be opposite spin. One up, one down. Clear? Okay. So as I said, so S can have 2 electrons, P6, D10, and F14, right? So, and following that order, we can write electronic configuration. So this is called orbital diagram, this one. Just know the vocabulary, okay? This is called orbital diagram. But writing out with orbital as a letter is called electronic configuration. How it does work? It go, we have to write out all of them one on one. So if I have like 1s, what is the 1s means? If I have 1s1 as exponent. So what this exponent mean? What the previous, you see, early big number, what the big guy says? Tell me what I means. I mean, exactly. And one telling that is in the first level, right? If you look at the periodic table, also saying same thing. One means it is the first level, right? First period. And so the prefix number saying that which level the atom is, okay? Or the electron is. Which level of electron, right? Which level it is in. And how the big S in the middle? What S says? What is the S means? S means, you see the orbital. S is the orbital. S is orbital. Which orbital electron in? So if it is S, that means in S orbital, right? P means P orbital. S, P, D, F, they are the orbital. And how about this exponent? This exponent means number of electron. This exponent means number of electron. Let's go. Some workshop. Do you have this table? Can with you? Josh? Yes. So look at in here. These are the S. You already know that S orbital element. All in the middle are called D. These are called P, right? Also remember that, anybody can remember, chapter 1 we learned that what is the main group element? Second? Main group. Who are the main group element? Who are this? S, P, D. Who are the main group elements? S and P. D are called transition metals. S and P are called, what is S and P? S and P are called, I just said that, main group element. So S and P orbital elements are called main group elements. But in the middle is called, remember chapter 1, when we were talking about the periodic table, we said that that's the subgroup and main group. Remember we said that? Main group and subgroup. This subgroup are transition metals. They're the D block element. So D block elements and the S block and P block elements. So this number, exponent number 1, it depending on where it is located. So where it is located, okay? So for instance, if I have an example in carbon. Let's go to carbon. So I have a 6 electron. If I draw 6 electron, then I have to go fill out electron from here. As I said, electron fill out from first level to upper level, right? What does it mean? It means that according to Bohr principle, electron going to be filling out following this order, right? So if I have a 6 electron, first we will go here, then here, then here, as much as I need to fill number of electrons that I have. I have 6 electron, then I will keep filling up in here. So let me write out in here. So carbon 6 electron. Start writing up from here. 1s. 1s, S can have how many electrons S can carry? 2. So 1s2. What's the next one? 2s. 2s, how many electrons can carry? 2 as well. And then how many electrons I have left? I started with a 6 electron. I'll just keep writing as much I need. So I have 2 more, then I write 2p, then I see how much electron I have. I have 2 left. Even though p can get 6, up to 6. But I have 2 left. So I'll put 2 in here. Listen. If I have the next one, I'll put 3 in here. Let's see, as I said, I said do a workshop. What did I say workshop? P2, right? P2 means in a p orbital, let me be closer to you. In a p orbital, it becomes second. So p is 2, right? First means very first one. Second means second one, right? So P2 means second box in the P level, second level. Second level, second box. Why? 2 means second level. Remember, prefix means a level. And this exponent means the box. What number of box the atom in? The atom carbon is in right here. 6. 1, 2, 3, 4, 5, 6. Is it? In here. So in here means P could be 1, 2, 3, 4, 5, 6. Remember, P have 6 electron. So 6 electron means 6 box. You see? 1, 2, 3, 4, 5, 6. You see? So when I have P2 electron, that means in second level, it is in second box. If I have P4, that must be in a fourth box. So number of box, I'm just making a word, number of box in the table will be telling the exponent, right? So you can follow this order, you can follow that way. You also can follow this way. For instance, if you write first level is 1s, second level is 2s, 2p, right? You know that, right? Third is 2s, 2p. Sorry, third, this is the third. So 3s, 3p, 3d. So 4s, 4p, 4d. 5s, 5p, 5d. 6s, 6p, and 5d. So this is the order I will be following, you see. So look at that, first one is 1s, right? From the diagram. Second one is 2s, you see? 2s. Third one is 2p and 3s. 2p and 3s. And then 2s, 3p, and 4s. Look at that. After 3s, it came 3p. Then came 4s. Then you go 3d, 4p, and 5s. You see how it's coming? So it's up to you how you to follow. The 4 way you can follow. Number 1 way is you can look at the order. Just remember the hiccup. Second thing is follow this order, right? Above principle. Third is follow this way. 1s, 2s, 2p, 2, right? 3s, 3p, 3d. The fourth way is, as I said in here, how, where it is located, which box it is in. So for instance, let's go with the beryllium, number 4, okay? Beryllium number 4. So that means in the table, in the box I give it to you, beryllium is located right in here. Right in here, you see? So beryllium would be 1s and 2s2. 2s2 because 2 means second level and 2s2 means in the second box. You see? So 1s2, 2s2. Can you do that? Yes? Okay. I want you guys to write all of them until 1 to until 18. So 1 to 18 I mean that in the periodic table, first and second and third. Having some good practice, you know. First level, second level, third level. First level, second level, third level, okay? So following that, either way you can follow. Write out until 18 in a row, okay? And can do that? Okay, someone want to come to the board? Yes.
Orbitals or just the configuration?
Orbital, you need to know how to look like orbital diagram. It is going to be in multiple choice question in exam. But as far as regular, regular basis, every chapter you don't need that. You just need to know how to write electronic configuration, not the diagram. Okay, someone please can write on the board. Please, one of you guys come on the board and write up 1 to 18. I want everybody writing in your notebook. I'll be walking around, helping you out, and I want to see everybody doing that.
You said 1 to 18.
Yes, 1 to 18. So any question is just ask me. I'll help you. Yeah, you guys work in a group, which is fine.
So you said 1 through 18?
Let's have some good practice. No?
2s, 1, yeah. And then 2s2.
2s3.
That's not S1 though. 5.
Oh,
4 arms. That would be.
oh, so that's not.
That'd be 2p1.
So is helium.
Yes.
Helium is S.
Okay. Okay. So.
Oh, right, 1 to 18.
So just
Electrical
find
conservation.
all the 18.
All the 18, yeah. I know you did it in intro chem, right? You did in intro chem?
Yeah.
Now you got that?
Okay.
Right, and then 3S1.
Yeah, it will be good practice for you.
Yeah.
3S1, right? And then
Yeah.
3S2. It's the same thing.
Yeah. Maybe down. This one's located on 5, right? 4 and 5. So what row is it in? The second row. Second row, 2P, 1, 2, 3, 4, 5, 6. That's all bullshit.
Yeah. One S, then 2S.
Because the way you have it is you have it like that and these two.
Not together. I mean that
You gotta write
level. First level, second level.
Oh.
This not level.
Okay, what is
This
this?
means that's the way you progress.
Oh, my bad.
That's the way you progress.
Just do it, it'd be 2S1.
That's the level is
Not
not
actually grouped like
No,
that.
not
So
grouped.
you're 2S2
even.
and then 2.
So it's like
Oh, it's
here,
the
here, here, here.
I mean, it's the same thing.
same shit, they just write everything else before.
Whatever comes next after.
Oh, it doesn't fit.
It does, but it goes from P6 and then it starts at
Well, we started at 10.
Take it off. Take it off.
Because really, you're just writing the same thing and adding like a number.
Because next class we'll talk about it. I discuss.
Oh, yeah, the way we do it, it's the same way how it's talked about.
Just check. I know you always advance. Great.
Doing it differently, sorry.
No, if you do that. Either way you do. You follow either options, but if you do that.
So she's doing it like.
Yeah, because usually, like, this is actually pretty easy. Like, this is like something that I actually know.
Oh, really? So do that. Just do write few. Okay, what if you write like 15 to 18? Then I can see that you really can do 100. Right.
I think I did the same thing, like, you said just do 15 to 18?
Yeah.
Okay, yeah.
At least I know how.
Because you rewrite everything every time, kind of.
When you don't know,
Yeah.
good practice.
Yeah, it is practice, yeah.
Yeah. When you go home, you don't have to practice. It's just good for you and you to go for exam.
Yeah,
Right?
yeah,
That's why I mean to have practice in the class,
right.
Trust me, you go home, you don't have to practice.
That's true.
Right.
That's true.
That is
He knows.
Just take the test and figure it out.
Yeah.
It has to be.
I mean, it just goes all the way to hard, right? Yeah. This is like, sophomore year.
Yes, Josh. I know you do that.
Nice. how many blocks there are. Hydrogen on one S, first block.
So when you're doing that, you might follow this.
Oh, I was gonna ask you to do that.
Hard man.
This is a halogen.
Yes, this is gonna be helpful for you.
No, it's not.
Okay, so this is the one we started H, hydrogen, number 1 to number 10, then we go for number 11, all the way atoms with number 18 atomic number. This parenthesis, what does it mean? It means atomic number, right, or proton number. The proton and electron are same for the atoms. These are the atoms, they are proton. Look at the periodic table. You see their number, proton number. It is going to be same with their atomic number as well as electron number. So electron, proton, atom, all are same numbers with the atoms. Okay. So couple of things we like to introduce with these examples. First of all, we learned that how to write electronic configuration, right? In the screen you have this SPD, you have the order, you have other options in here, keep filling up from what to where. But we also need to learn their valence level, their core electrons. So if I show first one in here, how many level you have in here, first and second? How many level? Only first level, first energy level, right? And when you come in here, it becomes second energy level. You can see in here. First, helium stops in the first level. Then, after lithium, start with second level. From the lithium, is the second level. Then it go up to, look at that, all the way up to neon. Because, look at that, helium, beryllium, carbon, nitrogen, fluorine, neon. All of them are at same energy level. So, it always, look at that, 1, 2, 2, first, second, right? Then in it, second energy level. When you pass neon, so do you know, sorry, I'm just one more question, basic question I want to guys refresh that the last group number, what is that called?
Noble gas.
Noble gas.